All right, we're back with another video. Today we're going to talk about how to factor special products. So previously in a different videos in the sequence we have here, we talked about multiplying special products. And there were some shortcuts that we used, and we had the difference of squares and we had the sum of the squares. So we're going to now work in reverse. So remember, when we do products like FOIL, for example, we're taking factors and putting them into an equation. But today we're going to be given an equation and we're going to bring them into factors. All right. So just to review, this was the idea of the difference of two squares, where we have a squared minus b squared. And then what ends up happening is we split the two factors up with a positive and negative b value. And then we have an example here where we have x squared minus 9. And the reason this works is because we have a square value for x and a square that is 9. So 9 is 3 times 3. So anytime you have a perfect square value and there's a difference of it like this, we can use this technique. So it's x and x goes first in each factor, and then a plus and minus 3. So let's look at another example here. So in part A, we see that we have x squared and 25. 25 would be 5 times 5. So what ends up happening is we do x and x for each factor pair, and then plus 5 and then minus 5, because 5 times negative 5 would give us a negative 25. So again, we take the last value, we split it into the square values, and then we split the first one in the square values, and then we have a plus and a minus. Let's try the second one here, a little different. May not be recognizable at first, but when you start doing more practice problems like this, you'll see that this is a very common type problem. So in part B, we see that the first value is 4, which is a square value. It's 2 times 2. And then we have 1, and 1 is a square value because it's 1 times 1. So what we do is we take 2 from each the square values, and so we have 2z squared, because 2 times 2 is 4, and z times z is z squared. And then we have 1 squared here, so it's going to be 2z plus 1 and 2z minus 1. So again, we take the last value, we take the square of it, in this case is 1, we make 1 positive, 1 negative, and then we square the first value and put that in the first term of the factor. All right, let's try this now. So here we are with the perfect square trinomial. This is where we did 2 times the values in the middle, and we squared the first value, squared the second value. So how we factor this then is we have to recognize that the last value is a square and the first value is a square. So what we end up doing is taking the c value here and square rooting it. In this case would be 3. It's the value that makes it a square value. So that's 3. And because a is 1, we have x in here. And so if we work backwards from the shortcut, we would remember that it's 2 times a times b. So if I have 6 and I know it's 2 times a times b, I'd have to divide it, which would give me 3 as my value for b, because this would be a, which is 1, and then b would be 3. So we'd have our factor pair here. And then if we have a plus minus, so a negative positive, we would do the same method. So let's look at a problem here. So we have a 16 here, which is a square value, and we know that we have to divide b by 2. So that would give us 4. So this would be n plus 4 squared. Okay. All right. Then if we look at the second one, this one's a little bit different because now we have an a value that's greater than 1. We can use our 5-step method, which would work. We can also use our factoring of factors of 16 that give us 8 and so on. That would work too. These are just shortcuts once you recognize them, so that you don't have to do as much work. So when we look at B, the 5-step method would work, but it does take a little bit of time. So what we do in this case is we have a square in the front and a square in the back. And if we take the square roots of those, we end up with 2x and 3. Now, because it's a negative positive, that means that both factors would have to be negative. And so we're left with this. So again, if you take the first value and square it, and the last value, the c value, and square it, square root them, that would give you your factor pair for this. So square root the first, square root the second, and that, and then just pay attention to your sign rules. Okay. All right. Last, when we solve these things, remember we get an equation and then we want to factor it, and the factoring allows us to then solve it. So that means we need something set equal to 0. So I want to go over this equation because we haven't seen too many like this in our class. And what happens is we have fractions, and when we see fractions, we often have a fear and get scared and don't know what to do. But we want to clear fractions out. And so a common practice is multiply it by the greatest factor. So the greatest factor of the denominators, is going to be 9. So if we multiply everything by 9, we would get rid of the fraction. So if I multiply 9 times x squared, I get 9x squared. 9 times 2/3 would give me 6. 9 times 1 would give me 1. All right, so that's how we go from here to here. We multiply each side by 9. Why are we using 9? Because it's the greatest common factor that we have. Least common multiple. All right, so now we look here, and these are actually squares. So if we square root this and square root the c value, square root 9, we would get 3x plus 1, and then there would be 2 terms for that particular thing. Now we have to solve this. So that means that we have 3x plus 1 equals 0. And then we would solve and get x equals negative 1/3. Now, because there's a square here, there's only one solution. And when we get into graphs, we find out that this is a touch point or a turning point for that particular function, the equation. So it is a solution because it touches the axis. It doesn't actually cross it, which is why there's only one solution there. Okay. All right. Then here's a little pattern for you guys, that if you have an x plus a squared equals 0, they'll have a repeated root of a negative a value. Okay, so whatever a is, it's opposite of that. All right, so hopefully that helps you guys out with studying this concept.